The Excel examiner loves making 6-mark questions out of reversible reactions. So, and that's the type of thing that we have here. Production of sulfur trioxide is a reversible reaction. It has a sulfur trioxide, sulfur dioxide, and oxygen reacting together. The forward reaction is exothermic. That's important. Let's write on there exothermic. Complete the following table to state and explain the ideal conditions for the production of sulfur trioxide. Okay, what generally happens in these exam papers is you don't get a table like this to complete. This is here to structure your answer. So you need to imagine these things aren't here. And you just need to go through the conditions one at a time. And you need to explain about the rate, how the condition affects the rate and the yield each time. So we're going to do pressure first. So pressure affects rate. Okay, high pressure. If you have a high pressure, you have more particles. So I've not really given you enough space here to write this answer down. You need to write your 6-mark answers in full sentences. High pressure equals more particles. If you've got more particles, you've got more collisions. If you've got more collisions, you've got a faster rate. Okay, so that's rate. Now the next thing we need to do is talk about yield. Now for the yield, there's 3 rules you have to remember. One for pressure, one for temperature, and one for concentration. So rule number 2 here, increasing the pressure on a reversible reaction favours the side of the reaction with fewer gas molecules. So let's write that out before we go any further. Okay, we've just got to learn those rules and then write them out when we talk about them. Increasing pressure favours the side with fewer gas molecules. Okay, so we need to count the molecules. Counting the molecules is counting the stoichiometry numbers, the big numbers. Now there's no number before the oxygen there, so there's a 1. So 2 before the sulfur dioxide, 1 before the oxygen, so there's 3 molecules on the left. On the right, just the 2 before the sulfur trioxide, 2 molecules on the right. Increasing the pressure favours the side with fewer gas molecules. So increasing the pressure is going to push this equilibrium towards the right because there's less molecules over there. So high pressure equals high yield in this reaction because there are 3 molecules on the left and 2 on the right. Increasing the pressure favours the side with fewer molecules. There's fewer molecules on the right. So we therefore want to do this at a very high pressure ideally, because that will make it fast and a high yield. Temperature next. Okay, so the rule for, rate first. High temperature. If you have a high temperature, the particles have more energy. That means the collisions between particles have more energy. Equals collisions have more energy, and that equals fast. Again, needs writing in a full sentence really. Yield next. Okay, yield. What's the rule for temperature and yield? The rule for temperature and yield is the top one here. Increasing the temperature on a reversible reaction always favours the endothermic reaction. So that's what we write out. If you write it out, you get a mark. Increasing temp favours the endothermic reaction. Now if you remember, one of the reactions is always exothermic, one is always endothermic, and you don't know which, that's why you're told in the question. The forward reaction here is exothermic, so the backward reaction therefore, the backward reaction is endothermic. Now increasing the temperature favours the endothermic reaction, the backward reaction. So in this case, increasing temp, inc for increasing temp favours the backward reaction. So what do we want here? Increasing the temperature makes a high rate, but increasing the temperature reduces the yield. It favours backward reaction, so that reduces yield. So we've got opposing forces reduces, that's what I was going to say, wasn't it? Reduces yield. We've got opposing forces. High temperature makes it fast, but high temperature reduces the yield, makes more of the reactants. So high temperature, low temperature. Well, by the time you see this, there's going to be another option in there that says medium temperature, because it's neither high nor low. So I'm going to change that in the version you see. Medium temperature, a compromise temperature. We need a compromise. Okay, last one. With catalyst, without catalyst. Well, with catalyst is the answer there. Catalyst rate. Catalysts speed up reactions. By providing an alternative route that requires less activation energy. Okay, yield, no effect. So catalysts speed up the forward reaction and the backward reaction, therefore they do not change the yield at all. Either way, we do it with a catalyst because it makes it faster. Okay, so we've got a very standard 6-mark reversible reaction question there. You need to be able to answer those. On the pre-release material, it looks like we're going to have one on the 2022 paper. All these questions on elshamhighchemistry.com.